Hello friends, welcome back. In the last lecture, we simulated 3 degree of freedom equations of motion for the aircraft in MATLAB, in Simulink using the MATLAB function block, and finally using the MATLAB 3DOF block, Simulink 3DOF block. All right. Now today we will be we are almost ready with the aircraft 6 degree of freedom equations of motion. Now we will be focusing on 6DOF block. So these blocks you can actually view in the library browser, aerospace block set, equations of motion, 6DOF. So we will be dealing with 6DOF equations of motion, which looks something like this. So let me go to the help model for this. Likewise, we have gone for the 3DOF block. So this is the block for the 6DOF equations of motion, and the equations are written in this format. So here equations will be in the matrix form. For example, total velocity is in u, v and w, body axis u, v and w. Similarly, rates are p, q and r. Similarly, about the moments. And we have these equations already mentioned, phi dot, theta dot and psi dot. So before we get into this directly into simulation, we need to define the parameters for 6DOF simulation. So let us go ahead and do that. So let me write here 6DOF simulation. All right. So now we had already written the equations of translation dynamics u dot, v dot and w dot. Let me go back there. Yeah. So these are the equations for u dot, v dot and w dot, where fx with the forces are written in L sin alpha minus d cos alpha plus T max into delta t minus g sin theta. Let me rewrite this equation there. All right. So we have u dot equals to 1 upon m L sin alpha minus d cos alpha plus T max delta t minus g sin theta minus q w plus r into v, and v dot is 1 upon m. Now since we have 6DOF motion, so I will be writing all the 12 states. So this forces in y direction, this is aerodynamic forces. So there is no propulsive forces in the body y axis, and these are the gravitational forces g sin phi cos theta minus r into u plus p into w, and finally we have w dot equals to 1 upon m minus L cos alpha minus d sin alpha plus g cos phi cos theta minus pv plus q into u. So this equation is equation number 23. All right. So here forces in the y direction, aerodynamic forces, let me consider this as capital Y, which is nothing but a side force, and the side force is modeled as similar to the aerodynamic forces, half rho v square s into cy, and the modeling of cy can be done as cy equals cy naught plus cy beta into beta plus cyp into pb by 2v. This pb by 2v is done to non-dimensionalize this parameter. cyr into RB by 2V. So here V is capital total velocity, not the side velocity, plus Cy del A into del A, that is aileron deflection, plus Cy del R into del R. Here Cy is nothing but side force coefficient. Which is obviously dimensionless. And PB by 2V, RB by 2V, these are to make it dimensionless. Since this is a coefficient. Alright. So what is the unit for P, for example? Radians per second. B unit is meters. Here velocity is meters per second. So we get radian. This again unitless. Alright. Next we have from rotational dynamics. We had written equation 16. Let us rewrite equation 16. As L equals to P dot Ix minus R dot Ixz plus QR Iz minus Iy minus Ixz P into Q. Moment about Y, we have Q dot Iy plus R into P Ix minus Iz plus Ixz P square minus R square. Here yawing moment N equals to minus P dot Ixz plus R dot Iz plus P into Q Iy minus Ix plus we have Ixz to Q into R. Let me take this as equation number 24, this as 25, and this as equation number 26. So for the 3-DOF block, here P and R was actually 0. So then we obtained moment about y-axis as Q dot equals to My divided by Iy. But if you look at equation 24 and 26, here we have rolling moment and then the yawing moment. Here we have P dot term, here we have R dot term. Here we have P dot term, here we have R dot term. So we note that lateral directional dynamics are completely coupled with each other. So we do not have an ODE equation in terms of P dot and R dot individually. Alright. So hence I have written this in this way. We have to convert this equation to ODE form, P dot and R dot equation. One way to do that is find out R dot from here and substitute in equation number 24, or find out P dot from here and substitute in this equation. So what we'll do is we'll find out what is P dot and what is R dot. So we have to find P dot and R dot equations separately. So from equation number 26, we can write R dot equals to N upon Iz plus Ixz upon Iz into P dot minus Iy minus Ix upon Iz into PQ minus Ixz upon Iz to Q into R. Now substituting this R dot in equation 24 and writing in terms of P dot. Substitute in equation 24. All right. So then we have P dot equation equals to L upon Ix plus N upon Iz plus Ixz upon Iz. We have P dot minus Iy minus Ix by Iz PQ minus Ixz by Iz Q into R Ixz upon Ix minus Iz minus Iy upon Ix to Q into R plus Ixz upon Ix P into Q. So we have two P dot terms now. We have two P dot terms here in this equation. So we can further write P dot. I am bringing that P dot equation to the left hand side and taking common 1 minus Ixz square upon Ixz equals to L upon Ix plus Ixz upon Ixz into N plus P into Q Ixz upon Ix minus Iy minus Ix upon Iz Ixz upon Ix minus Q into R Iz minus Iy Ix plus Ixz square upon Ix into Iz. Further we can write P dot Ix Iz. We have here Ix Iz minus I square Xz equals to L upon Ix plus Ixz upon Ix Iz into N plus, let us take LCM here as well. We have Ix Iz to Ixz minus Iy Ixz plus Ix Ixz. Similarly here minus Q into R, we have Ix Iz Iz square minus Iy Iz plus Ixz square. Further, let me bring that to the right hand side. P dot equals to Iz upon Ix Iz minus I square Xz. I am directly multiplying with the terms on the right hand side. We have L over here plus Ixz upon Ix iz minus ixz square into n plus ixz upon ix iz minus I square xz. The brackets we have ix minus iy plus iz to p into q minus iz into iz minus iy plus I square xz divided by ix iz minus I square xz multiplied by q into r. Now for simplification, I am considering capital gamma equals to ix iz minus I square xz, gamma 1 equals to ixz ix minus iy plus iz upon gamma 2 iz into iz minus iy plus I square xz upon gamma 3 is iz upon gamma 4 equals to ixz upon gamma. So this nomenclature I have considered again from the same book, Small Unmanned Aircraft by Randall Beard. So finally we can write P dot equation as gamma 1 P into Q minus gamma 2 Q into R plus gamma 3 into L and plus gamma 4 into N. So this is equation number 27. All right. So finally we have got P dot equation, ODE equation. Now after this P dot equation, let us first write Q dot equation, that is Q dot from equations number 16 is written as Q dot minus P into R Ix minus Iy Iz upon Iy minus Ixz upon Iy P square minus R square plus movement about y axis divided by Iy. Now we can write this as Q dot equals to PR Iz minus Ix divided by Iy minus Ixz divided by Iy P square minus R square and plus My upon Iy. Now consider this as capital gamma 5 and this one as capital gamma 6. So finally we can write Q dot equation as capital gamma 5 into P into R minus capital gamma 6 into P square minus R square plus movement about y axis divided by Iy. So this is equation number 28. All right. So now we are only left with R dot equation. So we substitute P dot that we have got earlier in R dot equation. Hence equation number 26 can be written as we have r dot equals to n upon iz plus p dot ixz upon iz minus pq iy minus ix upon iz minus ixz upon iz into q into r. R dot equals to n upon iz plus I am substituting p dot here, we get ixz upon ix iz minus I square xz into L plus I square xz upon iz ix iz minus I square xz into n plus I square xz divided by iz into ix iz minus I square xz into ix minus iy plus iz into p into q minus ixz divided by iz curly braces iz into iz minus iy plus ixz square divided by ix iz minus I square xz. This multiplied by q into r minus pq iy minus ix by iz minus ixz divided by iz into q into r. Then this r dot can be further written as n into 1 upon iz plus I square xz upon iz ix iz minus I square xz curly braces close plus ixz upon ix iz minus I square x into L plus p into q curly braces I square xz by iz into ix iz minus I square xz. Here we have ix minus iy plus iz minus iy minus ix by iz. So finally curly braces close minus q r ixz upon iz plus ixz upon iz ix iz minus I square xz. In the numerator we have iz into iz minus iy plus I square xz. Finally curly braces closed. We are not done yet. Further we can write r dot equals iz into ix iz minus I square xz. We have here ix iz minus I square xz plus I square xz into n, plus we can simply write this as gamma 4 into L plus P into Q. Let me take it as an LCM. First let me write the numerator term, I square xz into Ix minus Iy plus Iz minus Ix Iy Iz minus Ixz square plus Ix square Iz plus Iy Ixz square. In the denominator we have Iz into Ix Iz minus I square Ixz. Then we have, this bracket is closed, and we have minus Ixz QR divided by Iz 1 plus Iz into Iz minus Iy plus Ixz square divided by Ixz minus I square xz. Further we can write R dot S. We are almost done with R dot expression. R dot equals Ix by Ix Iz minus I square xz into n plus gamma 4 into L plus P into Q. So this can be written as Iz, this curly braces, Ixz square Iz minus Ix Iy. All other terms got cancelled, so we have this left over here, Iz into Ix Iz minus I square xz. Finally minus QR Ixz upon Iz Ix Iz minus I square xz plus Iz to Iz minus Iy plus I square xz. So this actually goes over here, Ix Iz minus I square xz. R dot equals to Ix upon Ix Iz minus I square xz into n plus gamma 4 into L plus I square xz plus Ix into Ix minus Iy divided by Ix Iz minus I square xz into P into Q minus Ixz Ix plus Iz minus Iy divided by Ix Iz minus I square xz. This is multiplied by Q and R. So we are almost there. R dot equals to, we have I square xz plus Ix minus Iy divided by Ix Iz minus I square xz. This is P into Q minus Ixz Ix minus Iy plus Iz Ix Iz minus I square xz Q into R plus gamma 4 into L plus Ix upon Ix Iz minus I square xz into N. Finally, we can write R dot S gamma 7 into PQ minus gamma 1 into QR plus gamma 4 into L plus gamma 8 into N. Consider this as equation number 29. So, where gamma 7 is given as I square xz plus Ix minus Iy divided by Ix Iz minus I square xz, and gamma 8 equals to Ix by gamma. All right. So, this was little bit lengthy over here, but as a flight dynamics and control person, you only need to derive this once. Now, we'll consider the same UAV that we took before, and we have few more parameters left to define, that is the rolling and the yawing moment. L and N are generally modeled as L equals to half rho v square. S, the reference length here will be B. All right, it should not be caught into CL, and N is half rho v square S into B into Cn. So, likewise, we modeled the pitching moment. We have to model the CL and Cn as well. So, CL is given as CL naught plus CL beta into beta plus CLP into PB by 2V plus CLR into RB by 2V. Again, I am non-dimensionalizing this, plus CL del A into del A plus CL del R into del R. Similarly, Cn is given as Cn naught plus Cn beta into beta plus Cnp into Pb by 2V plus Cnr into Rb by 2V plus Cn del A into del A plus Cn del R into del R. All right. Now, we know that likewise we modeled alpha. Similarly, here the side slip also will be changing over time. So, let me draw the free body diagram, how to find the side slip. So, if we see the top view of any aircraft, consider this is an aircraft model. And if we have velocity in this direction, free stream velocity, then the angle which it makes with the body x-axis is the side slip angle beta. All right. And in this direction we have small v, side force, sorry. So to find side slip angle, we can easily get it from sine beta equals to perpendicular upon hypotenuse, nothing but small v upon total velocity v infinity. All right. Then the process for finding delta E trim and alpha trim remains same. So now we are only left with the aircraft lateral parameters that will input it in the next lecture. So let us stop it here. Thank you.